Hello and welcome to another Cram Your Medicine tutorial. Today we're going to be talking about the basal ganglia and how they work. Okay, so the basal ganglia are a group of nuclei located at the base of the brain, and they're involved in control of voluntary movement. Okay, so they assist our body in any voluntary motor movements. Okay, so if I'm going to move my arm to take a sip of my coffee, the basal ganglia are involved. Okay, so let's look at what we have on the screen here. We have a few figures, okay, and the first thing we need to note when depicting these figures is that anything red is an excitatory stimulus or an excitatory stimulus. So these red boxes depict a nuclei or a section of the brain that increases activity in whatever it acts on. The dark green boxes depicts nuclei that inhibit other parts of the brain that they act on. Okay, so with that in mind, let's go through. Let's start by talking about our two pathways, the direct pathway and the indirect pathway. Okay, the first thing we need to note is that the direct pathway stimulates muscle movement, okay? And the indirect pathway inhibits muscle movement. Okay, so let's see how this occurs. Let's go through this here. Okay, so let's start at the putamen. Okay, we'll touch back on the primary motor cortex and the substantia nigra after, but let's start with the putamen. Okay, so the primary motor cortex, we want to initiate a muscle movement. Okay, so we're going to flow down the direct pathway. So the primary motor cortex is an excitatory stimulus, or it's an excitatory part of the brain, okay? And it excites the putamen, all right? Same on this graph. So we have the primary motor cortex exciting the putamen right here, okay? So if we follow the direct pathway, which is this arrow right here, let's put direct there. So if we follow this arrow down, we have an excitation of the putamen, okay? This increases its activity, all right? So I'm going to put an arrow up right here. So increasing its activity, okay? Increasing the putamen's activity increases the inhibition of the globus pallidus internus, okay? So it's going to decrease the activity of this nuclei. All right, and this is where people can get confused, okay, because there's some double negatives going on here. All right, so by the primary motor cortex increasing the putamen's activity, it's increasing an inhibitory stimulus, okay? This increase in the inhibitory stimulus decreases the activity in the globus pallidus internus. All right, it's the same in this graph. So an excitatory stimulus in the putamen in the direct pathway is increasing the inhibition of the globus pallidus internus. All right, and what is that going to do? Well, this is an inhibitory nuclei. So reducing this activity is going to decrease the inhibitory stimulus to the thalamus. All right, and when we decrease inhibition, it means that we increase the activity in the corresponding nuclei. All right, so we increase the activity in the thalamus. When we do this, we have an effect on our motor synapses. Okay, the thalamus excites the primary motor cortex. So when we increase this activity, we are sending a signal back to the primary motor cortex saying, all right, let's move our arm. We actually initiate a muscle movement. All right, so that's through the direct pathway. Okay, so with that in mind, now let's talk about the indirect pathway. So maybe we're sending a stimulus from the primary motor cortex that isn't helpful in moving my arm or our arm. Okay, so it's the basal ganglia decides it delegates this to the indirect pathway to inhibit this movement. Okay, so let's start here again. The primary motor cortex. Okay, this time it still sends the excitatory stimulus to the putamen, just like in this graph, excitatory to the putamen, except this time we're going to go down the indirect pathway. Alright, so this is the indirect pathway here. Okay, in the indirect pathway, we have the globus pallidus externus involved. Okay, so flow down the indirect pathway. So once again, the putamen activity is going to be increased. Okay, that's going to increase the inhibition towards the globus pallidus externus. Okay, so an increase of inhibition decreases this nuclei's activity. Okay, decreasing the activity in this nuclei will relieve its inhibition towards the globus pallidus internus. Okay, causing this to increase its action. Alright, increasing the action of this nuclei, which is normally inhibitory, increases the inhibition on the thalamus. That decreases the thalamus's activity. Okay, see, it's not difficult, just you have to think about it in a way of, if I'm increasing an inhibitory stimulus, what am I going to be doing to the next nuclei? What am I going to be doing to the next part of our flow chart? Alright, so when we decrease the activity in this thalamus, that means we're going to have a lower excitation of the primary motor cortex. Not as many synapses are going to reach the primary motor cortex, telling us to initiate that movement. Okay, and it results in not firing a motor stimulus to the corresponding muscle. Okay, and it's the exact same here if we look. So let's follow the indirect pathway again. The putamen increases in activity. This increases the inhibition of the globus pallidus externus. That decreases the inhibition towards the globus pallidus internus, which increases its inhibition on the thalamus, which decreases the excitation on the primary motor cortex. Okay, it's the exact same on this figure. Okay, so before we send off here, there's just two other things we have to note. Okay, the substantia nigra. So what does this do? Think of the substantia nigra as the handbrake. Okay, so when we want to initiate a movement, we have to take the handbrake off. We have to send some stimulation. Okay, so what the substantia nigra does is it receives cortical inputs from the motor cortex, telling it that we are starting a movement. And what it does is it stimulates the direct pathway, and it inhibits the indirect pathway. Okay, when we stimulate the direct pathway and inhibit the indirect pathway, it signals for a muscle movement. It's a stimulus for a muscle movement. Okay, the other nucleus here which we have to touch on is the subthalamic nucleus. Okay, the subthalamic nucleus provides feedback stimulus to this system. Okay, and it's a feedback stimulus from fired motor coordination. Okay, so when we fire a motor stimulus, it becomes active to downregulate that stimulus. So when we fire a motor synapse, the thalamic nucleus becomes active and it stimulates the globus pallidus internus, thus to reduce the activity in the thalamus. Alright? Also, it should be noted that through the indirect pathway, the subthalamic nucleus its inhibition is decreased. Okay, so normally the globus pallidus externus is inhibitory to this nuclei. Okay, and as we noted through our indirect pathway, this nucleus, the globus pallidus externus, its activity is decreased. That results in an increase in the activity in the subthalamic nucleus, which results in kind of a reinforcement of the inhibition, or a reinforcement of the indirect pathway, and an inhibition on the primary motor cortex. So that's generally, kind of quickly put, the basal ganglia. If you have any questions or feedback, feel free to comment below. Otherwise, thank you and good luck studying.